Welcome back again to my channel Balvikan Bharti with your own mentor Avila Sarkar. We are on the way of discussing the theories regarding quadratic equation, and there we have reached to a term that is being established while we are establishing the roots of a quadratic equation, a generic quadratic equation. A term we have used, that is b square minus 4ac, and that we called as a discriminant, that is discriminant. This is called the discriminant. This is a special part of the roots. Now, as we said, that this will carry some values for which the roots will behave differently. So first of the term, if b square minus 4ac is equal to 0, that means discriminant is 0. That is the discriminant 0. What does it is placed? The roots of the quadratic equation being established by this discriminant. This only separates the two discriminant, and they being familiar or distinguished separately. If this term is not there, then in that case x1 and 2 is equal to only b by 2a. So that means there is no variation of 1 and 2. 1 is also b by minus 2 by minus b by 2a, and x2 also minus b by. So when it is possible, when this term is equal to 0, that means this condition. So that means we can conclude, if this is discriminant is 0, both the roots are same. So the same thing we have discussed in the last class, where we have taken an example, x minus a whole square is equal to 0. That means for a perfect square, for a quadratic equation where it can be expressed into a perfect square, then roots are same. That means if an expression means, why I am saying, because the left hand side completely all the terms, if it is brought in left hand side, other side only 0, if the expression can be represented or expressed as a complete square of complete perfect square, then both the roots are same. So like that, if I can represent the whole expression into a square of some terms, complete terms, then it is a. So for example, if I say x square minus 4x plus 4 is equal to 0, this is also a quadratic equation where this part is the expression, and what I can do, x square minus 2 into x into 2, that means this part, plus 2 square. Now I can write it like that. So this will turn into a square minus 2ab plus b square, that means a minus b whole square. Now you see, I can represent this expression into this. So this, if it is possible, then both the roots are same. This is only possible where directly seeing the expression, this expression, if I put the value, what is b here? Minus b. Minus b means minus 4 whole square, minus 4 into what is a? 1 into 1. What is c? 4. Now see, what is the value? Minus 4 square means 16, minus whole square, that means plus 16 minus 16. So this is equal to 0. So now if I calculate the discriminant value, then I can say, without calculating like this, I can say both the roots are of same value. Okay. And the values can be calculated there from this expression. What is now minus b? So minus b, and b also minus, so minus 4 by 2 into a is what in this expression? Sorry, in this expression 2 is 1, a is 1, so this is 4 by 2, that is equal to 2. Now see, both the values are 2, so now if we express in this way also, both the values will be x is equal to 2, x is equal to 2. Now I am getting it there itself. So this expression can be used to get where if discriminant is 0, what is the value of the root also I can calculate directly. Fine. Okay, this is the first condition. Now the second condition, when if it is greater than 0, it is greater than 0, that means x and 1 by 2 and 1 and 2 both b square minus 4ac by 2a. That means this is greater than 0 means this is specifically greater than 0. That means this expression, this the inside this bracket, it is not negative, so it is real value only. As we know, the under root any value which is less than 0, it will give a non-real value, imaginary value, that is have no existence, but even we can represent it in some form so that we can solve our mathematics problem. Just for the sake of the expression, we have taken some more variables there, but that is a keep apart. But as of now, in reality, if this term, anything below the square, if it is more than 0, that means it is real. Now if for real value, it won't be equal to 0. At least if it is more than 0, that means I will get either something which is a root, okay, it is a root or a perfect square. That two things can be possible. If it is greater than 0, it could be a perfect square or it's not a perfect square. So if it is a perfect square, then this term will turn into a real number, okay, is a natural number. Otherwise it will be under root. So there could be possible, if it is a only greater than 0, not perfect square, then the roots will be what? It will be something, I am just writing it in the form of let's say e. So I will get something like that. The roots will be is a, what do we say? We can say it as surd. That means a mixed surd. There is a real number or a you can say the natural number and a surd. So this is a mixed surd. You can say just like 2 plus root 3 and 2 minus root 3. This will always come in a conjugate form. Means the roots will be always in the form of conjugate. That will be, if I multiply together, I will get a real number, means a natural number, not a surd. That will be, because if I multiply to this 2, I will get a root free number, means the square root will not be there. So I will get something, this one. So if I multiply conjugates which is of a surd, I will get a real number. Okay, so that is part 1. Second part, if it is a perfect square, I will get something, let's say f is a perfect square. So from there I will get something like that. Okay, so this has a two mode. One is greater than 0, that will definitely give a real number, but that could be a surd. If it is a perfect square, I won't get a surd. That is definite. Okay, this is the part. Now the third one, which is a very important, or it is separating the complete you can say the real mathematics to a imaginary mathematics, where if it is this less than 0, that means that x1 and 2 means both the roots I'm talking about plus minus b square minus 4ac by 2a. Now if it is less than 0, that means this part is cannot come out of the root. That means if I say this is all imaginary, under root of minus, it cannot be defined in mathematics in a real term. So for that we brought a term where I will define under root of minus 1 is a specific signal sign, that is a small I. So and for any case 3 can come out, we can write it like that, root of minus 1 into root of 3. So we can separate it in this form, where minus 1 and 3 all multiplied together will get minus 3. So we distinguish in this way, in a real term into an imaginary term. Ultimately this can be defined as I, so this can be defined as 3i. Ultimately this is a separate chapter altogether, but you won't get any real value of x and y. This is a imaginary, but although this will also come as a conjugate form, because if I say a plus ib is one of the root, other will definitely be a minus ib. This a I am not the same a I am using here, or let's say for clarity, in this form you are getting, so other root you will also get in this form only, and if you multiply that it will be ib whole square a square minus of I square into b square, where I square is equal to what, minus 1 if it is equal to I, so this square is equal to I square, and minus 1 whole square, that means only square will come out, means square will be remove from this equation. That means I mean to say minus 1 whole power half that whole square. So that means this power order will cancel each other, this minus will remain minus, so that will be equal to minus 1. So I square is equal to minus 1. This is true. So if I put I square is equal to, now this will turn this into a real numbers. Okay, now a square minus of minus b square. Now this minus minus will plus, and it will become a square plus b square. Here nothing is imaginary. So I understand how they are relating. If I multiply the two roots which are conjugate or which are conjugate in the form of suds or imaginary number, the ultimate result of multiplication, this is equal to a real number. So that means if I multiply the two roots, it will give you a real number. That means the expression which will carry the real roots, the expression itself will not carry any imaginary number. That means if I say, for example, I'm taking it for, it has some two unreal values, imaginary values, but still none of the numbers you will find here is imaginary. So that means ultimately if two roots being multiplied, I will get a real expression. Understand? So I forgot to tell you what the roots are called. If b square minus 4ac is equal to 0, the roots are real and equal, isn't it? If 4ac greater than 0, these are distinct, that means two are different and real, there is no question about it, this will give you a real. Third one is 4ac less than 0, this definitely be distinct, Okay, but imaginary. There is no existence in the real mathematics. There is a separate segment to discuss these problems. Okay. Yeah, this again also called as a complex or sometimes non-real, complex and non-real. Okay, these are the terms being used to describe those terms where that I will come. So this is the segment. Okay, fine. Now the part that I have to discuss is solving method. Solving methods of quadratic equation. The one method I already said you, that is while I am doing calculating x1 two roots. This is one method, is a direct method. You can use it. Means when you will get a expression or a equation like that, here this will be given in the equation. So you can put the values of this. You will get two values. For example, if I say 2x square plus 3x plus 1 is equal to 0. Now a is equal to 2, b is equal to 3, c is equal to 1. So this when you write the value of a, b and c, because the real equation all terms are given in positive. Okay, now in any case, if I get any one expression 2x square minus 3x minus 4 is equal to 0. So while you write the values of a, b, c, you have to consider it in the form of first in the plus form. So you have to think like that in your head also, you can think. So while writing you won't be confused, or else you can write one step this way, then it will be easy to write the values, because otherwise you will always fall in trap to forget the signs. So if you once put it in like that, so whatever inside the bracket, the value of that constant. So I have picked b is as minus 3 and c is minus 4, not 4 only, because I have put the expression in the form of the generic form, where every terms is being added with the plus sign, and the remaining sign, it will be the property of the constant itself. Understood? So this way I express. Now if once you will get this a, b, c, you can put it like that with their sign, with the sign of the value. So I will put it in that. How will you do? Whatever sign is there, it will be there. Minus, that will be minus 3 I have to write, plus minus, b square means minus 3 square. So you will never be in a position to do mistakes. So a is equal to 2, 2 into 2 into c is equal to minus 4, and the remaining 2 into a means 2 into 2. So this is the process of doing that. Then after you do calculation. So as you know, minus of something whole square, it will give you plus. So there is no harm in it. When you do minus into minus, so this sign will affect the overall sign. So if you can eliminate, you can eliminate in the first step, or you multiply and keeping whole thing as minus, then after you can eliminate. It's up to you, but be cautious when you work with minus and plus. Is always a silly mistake people do. Students does it very frequently. Okay, so be cautious. So this is the one method. That two method is will come in the process of calculating. I done the squaring up. So this is the direct method. When the second method is just related to this squaring up, or what is the real term? By squaring, factorization, completing square, or this is the term people are using, completing square. So this is the method. While I'm just bringing in this form the process that is being followed. So for example, 2x square plus 3x plus 1, let's say, okay, is equal to 0. Now I am to put it in the squaring form. So what I will do, simply I will remove the coefficient first, as I did in that case. So this is the first form. Then after x square plus x is there, so this 2 term automatically will come, and remaining term I will adjust. So 3 by 2, unless I do 3 by 4, it won't be the same. So then after, if I presume it is a b, so this square has to be there. As I brought it that, so I have to bring it back, so that thing will balance, then plus 1, now 0. So now x plus 3 by 4 whole square, and the remaining term will go that side. So this will be 9 by 16 minus half. If I do that, 16 will be the LCM, 9, and this will be 8, that will be 9 minus 8, that is equal to and 1 by 16. Okay, now see, if I do square root of this left hand side, I will get plus minus 1 by 4, because anything being done square root, I will get the result in the both form, plus and minus. So now 3 by 4 and plus minus 1 by 4. So take plus, you will get one value, take minus, you will get one value. So this is the second method of calculating, or you can say calculating roots. Okay, so the third method is factorization. This is very tough one, you need some practice. It won't be very easy, or you will not able to be master of this unless you practice lot. Why I'm saying, let's say x square plus 5x plus 6. I'm just putting it in the form because there is no such theory that will describe, rather than I will give some examples. So now factorizing means multiply this coefficient with this coefficient and break it into such a way that I will get this middle term. But you have to keep in mind that then when I will put it here, I will get something, so that I will break it into factors. I will bring some two terms which will multiply, will give you this one. So I am doing for this, doing for you, so that you can understand. Now 6 into 1, it is 6. Now 6 can be broken into 1 into 6. What are the factors of 6? 1 into 6, 3 and 2. Now see, 5, if I use these factors, means this and this multiplied, I have to bring this. So this is also possible. If I write it that like that, let me do it like that. Where I am stucking, I will show you, so that you can understand it better. So I am using the first two factors. I have to use either these two or these two. What? Because factor will always come in pair. So whatever factors will come, I can try all of this. Now here it is 2 only, so I will try 1 by 2, 1 by 1. So if I blindly follow the first one without thinking, why I am saying, because this concept will has to be developed by your own. I cannot feed it in your mind. That's why I am showing where you could go wrong. If I can understand where you could go wrong, then the other way you can easily understand. So x square plus 6x minus x plus x is equal to 0. Now what I have to do for first two term, where order of 2 and order of 1 is there, that has we have to take something common, so that keeping in mind, while I take common something out of this two term, I will get something inside the bracket that has to match, while I will take common something which is common to this two term, and I will get the same factor in bracket what I am getting here. So if I take x is equal to x common, so I will get x plus 6 here. See, x, if I take x common, so x x will remain here. From 6x, if I take x common, I will get 6 here. Now other two terms, as because this is minus, if I want to take one common at least, I will take minus 1 common. Okay, because no other coefficients there with x, so only thing minus 1 can be taken common, so that will give you x. So first term it is matching, but what about the second term? If I take minus, so I definitely have to put this minus, otherwise minus and minus will not give the original plus 6. So now this is differing from this, so I am somewhere taken a wrong choice, otherwise this must be same as this. So this you have to calculate in your mind, so that while you doing the second step, you have to reach your thought up to this. So this is the very critical one. You have to project your idea to the third step while you computing the first step. Okay, now while you take the second choice, how the thing will change, you see. Instead of this one, I will choose the second one. X square, 5 can be written as 3 plus 2 into x plus 6. Now break it into two part, 3x plus 2x plus 6 is equal to 0. Now out of this two term I am taking x common, so x plus 3. Now out of this two I will take 2 common, so this will again, now see this term and this term are same, so this has to be my aim, where after taking common these two factors has to be same. Now why I am doing that, why it is needed to be same, because out of these two term again I will take this term common, so the remaining will be x plus 2. Now it will break it into two factors which can be multiplied to get this. So while I am doing this way, I will get two factors. Now if I multiply this, definitely I will get this, because I am not doing adding something or deleting something, I am just putting it in the form. So as after getting this, you can say if two factors are multiplied to get 0, there is always a possibility either one is 0 or both is 0. If doing both is 0, now a maximum possibility is that both can be 0. Now assuming this also 0 and this also 0, if I get x value is real, then both can be accepted. So x plus 3, where x is equal to minus 3, this is real. X is equal to minus 2, that is also real. So both can be possible. Okay, understood. So either one is equal to 0, also will make this expression is equal to 0, or both can be 0, also make this equation 0. So my case is that if I take both is 0 for the sake of the understanding, if x, by doing that, if I get x is real value, so that is possible. So that there is two roots are possible, x is equal to minus 3, x is equal to minus 2, which will make this expression, this left hand side is equal to 0. Okay. So this is the two methods. Another two methods I have to discuss along with few more concept I will discuss in the next class. So thank you for now. Good night. If any questions, you kindly put me on a comment box. I will definitely answer it. Thank you for now. Good night.